So today we're going to move into section 13.7, which is probabilities when you're selecting more than one object. For example, if you're working with a standard deck of cards, we would ask you to find the probability of selecting one or more cards. Now, when you're working in a scenario such as this, we have to keep in mind that there's some important pieces to these problems that are different from the previous probability questions we did. So the first thing you want to know is how many objects are you selecting? If it's more than one, then you're going to work under these practices here. In most cases, you'll be selecting 2, 3, or 4 items. We usually don't go more than that, but we can. Second piece of information here is there a specific order to the cards you're selecting? So it's either a yes or no there. So if the answer to the order is yes, then we have one scenario in that probability calculation. An example of that would be, what's the probability you pull a 4, then a king? Okay, so there's a specific order to that. The 4 has to be pulled first, followed by the king second. In that situation, there's a key word. The key word is then. So when you're looking at these probability questions, if the probability has a then in it, then that would be an indication that you are dealing with selecting more than one object, and the order is very specific in that situation. If the answer to the question is no, then you're going to have multiple scenarios. Here's an example. What's the probability of drawing a king and a 5? The key word is and. And when you're dealing with probability, it usually indicates you have multiple scenarios. It also means we're going to usually add our probabilities together. So a king and a 5 could be understood as drawing a king followed by a 5, or a 5 followed by a king. All right, so the key word in this situation is and, king and 5. So you just have to keep in mind that it can be a king 5, but it could also be a 5 king. Whereas the other one, it would be a king then a 5, where the king comes first, followed by the 5. So those are important pieces. The third piece here that's critical is whether we can replace the cards after we pull them, or whether they have to remain out of the deck when you go to pull your next card. So that's with replacement or without replacement. With replacement, the denominator of your probability calculation will always stay the same, because you're taking a card out and then placing it back in, so your sample space doesn't change in size. However, without replacement, your denominator will decrease by 1 each time, and that's because for your first card pull, that card will not go back into the standard deck. So the deck starts with 52 cards, and then it drops to 51 cards. And the denominator will continue to decrease for each card you pull out of the deck. Do not replace it. So these are the 3 key pieces you have to pay attention to when we're moving into section 7 or 13.7 now. So our first example under these scenarios are, so from a standard deck of 52 cards, select 2 cards with replacement after each pick. All right, so you're going to take out 1 card, look at it, place it back in the deck, take out another card, look at it, place it back in the deck. So the question is, find the probability of a king, then an ace. All right, so the key word here is then. That means the order is important. And since we're replacing the cards, our denominators for each probability calculation we do is going to remain at 52 because there's 52 cards in the deck. Okay, so for this calculation, we need to find the probability of selecting just a king. Next, we're going to find the probability of selecting just an ace. And then what we do is we multiply those two probabilities together to calculate the total probability of selecting a king followed by an ace. So if you look at our standard deck of cards, in green I've highlighted the kings, right? There's one king in each suit, meaning there's 4 kings in the entire deck. So the probability for selecting just a king in this situation is 4 out of 52 total cards. Now in this case, since we will be multiplying the fractions as opposed to adding them, what we want to do is simplify this fraction first. It makes life a little bit easier in the end. So the probability of selecting a king simplifies to 1/13 here. Next, we're going to move to selecting an ace. Probability of an ace, right? So in purple, I've highlighted the aces. There's 4 aces out of the 52 cards available in the deck. So the probability of selecting an ace is also 4/52. And again, simplifying this will make life a little bit easier. So that simplified fraction is 1/13 too. Next, what we have to do is calculate the overall probability of selecting a king and then an ace. To do that, we're going to multiply the probability of a king to the probability of an ace. And that's in order with replacement. So that's 1/13 times 1/13, giving us a total probability of 1/169. 1/169ths. Again, leave it as a simplified fraction and never turn it into a percentage.